All right, so we are gonna go ahead and start with an example now using um, interaction effects between a quantitative variable and a qualitative variable so that we know exactly the interpretation that we should have. For this example, I'm gonna use the small car data set that we made. It's an engine, it has engine size, manufacturer, miles per gallon, and the weight of the car in thousands of pounds as predictors. So I'm just going to go ahead and run that piece without more explanation. So we have the car data, 10 observations, and again, we would have three predictors. I'm going to go ahead and create the model that we used. And remember that the levels for the qualitative variable manufacturer in this case is has as a base the Ford cars. So we're comparing against Ford cars. So let's go ahead and create the regression. Let's call it regression one, and we're going to use the ln function with miles per gallon as the response, and then we're going to just put engine size, weight, which are both numeric predictors, and then manufacturer. And finally, we're going to use the car data frame. Let's take a look at the summary for this. And again, we've seen this before. We have seen that weight is actually not a significant predictor in the presence of engine size and manufacturer, and because mostly because weight is very correlated to engine size. But for now, let's leave it there. Um, the interpretation we've talked about this, but let me just remind you in this: as engine size increases um, um, by 1 unit, whatever unit engines have. Then on average miles per gallon are going to decrease by about 1.5. So this is called the effect that engine size has on the miles per gallon. In effect, really means the change in the expected value of y for a given 1 unit change in the predictor variable. Now, weight, the same thing as weight. The effect of weight is as weight increases by 1 unit, in this case it's 1,000 pounds, then on average the miles per gallon decrease by about 0.80. In manufacture, we generally interpret it as the average difference in miles per gallon of GM cars compared to the class that you left out, which is the Ford cars. But now let's take a look at an interaction between, let's say, two variables. Okay, so right now we can explain about 95% of the variability miles per gallon. Again, we're using adjusted R squared, knowing that we are sort of adjusting based on the number of variables. So let's create a regression 2, and we're going to use the lm function again. Let me just reuse the code that we used, but now we're going to include an interaction between weight, which is the quantitative variable, and manufacturer, which is actually a qualitative variable. And let's call it regression 2. And let's take a look at the summary again for this. In this case, we have a significant interaction between weight, manufacturer, and actually between weight and the manufacturer. What that means is that now weight is not important, is statistically not important, but because the interaction is important, then I would want to leave both weight and the manufacturer, dummy variable, in there, even if they are not. Okay? We can see that now our adjusted R squared has increased from 95 to about 99. So we can explain a lot more of the variability of the miles per gallon of a car just by including that interaction. But now let's take a look at what does it mean that we have an interaction. Now let's interpret this model, and the way that we interpret things. So So let's interpret the model parameters. So now we have to take a look at the combined effect of the variables. So let's start with engine size. Engine size is only part, the estimate only contains the linear part of engine size is not contained in any other interactions. So the interpretation doesn't change. The effect is just as, so let's put it here, this engine size. And let's call these effect of engine size on miles per gallon. So we would say as engine size increases by 1 unit. And again, I can't remember the units for this particular example, but for the engine size, but it's just for illustrations. We're going to say on average, the miles per gallon decrease by about that. Okay, that's the effect of engine size on the miles per gallon. But now when we have to interpret the effect of weight, so the effect of weight, we see that weight has a negative effect, but you can see weight in two parts, in the equation on its own and also in the equation containing the interaction. So when we talk about the effect of weight, we have to sort of include the effect that the variable brings on its own, which is a negative effect, and also the effect that it brings by having the manufacturer GM, which is the dummy variable for GM. So if we look at it this way, the weight of the car has a negative effect. But if it is a GM car, that negative effect on the miles per gallon is magnified. So it's even more. So let's interpret it. We would say as the weight of the car increases 1,000 pounds, it's just those are the units, then on average, the miles per gallon change by, we can say change by a factor of, change by, let's say by this amount, this here, and then minus this, and then we would have to multiply that by manufacturer GM, which is the dummy variable. So what does that mean? That still doesn't explain exactly what it means for somebody who might not understand what we're doing. So because this is a dummy variable, we can go ahead and interpret the two options that we have. Remember, this can only be 0 or 1. So when we are interpreting an interaction with a dummy variable, it's a little bit easier. So we would say, we can say something like this: as the weight of the car increases by 1,000 pounds, then on average in miles per gallon, let's say decrease by this amount. And again, I'm not going to put minus here because I said decrease by this amount for Ford cars. Okay, if that makes sense. This is going to be 0. So I'm taking the first option where these dummy variables is equal to 0, and then that would mean for Ford cars. And then we would say the same thing, but now the decrease for GM cars is not going to be the same because it's going to be this minus. So it's going to be the combined effect on this. So the decrease is going to be actually, it's going to decrease by 2.1175. And again, I'm not putting the signs in there that they have because I'm saying decrease already, so I'm not going to include the minus sign in here. So in other words, when we do an interaction effect between a quantitative and a categorical dummy variable, it would be easy to go ahead and choose the two options that you have on the dummy variable and just basically say the effect that they have for those two dummies, for the values of the dummies, 0 and 1. But now in the language of the problem, Ford and GM cars. If we want to take a look at this visually, this is what happens. And I'm going to go ahead and we can look at the interaction plot between that. We can use a library, a package named sjplot. If you haven't installed it, you can go ahead and install it. But, I'm going to use it here, sjplot. And what it does is that actually plots interactions. The nice thing is that we already created that regression 2, that's the object where we saved it. And by default, what this does, you can say plot underscore model, and then put the type of plot that you want. You can go ahead and know more about this plot model option here, and you can see what it means to have a plot type equal to int, and that basically shows you the marginal effect of interaction terms. You don't worry about it if you don't understand what this means, but basically the idea is that you would plot the effect of the interactions between the variables. So a marginal means the individual variables by themselves. So we can say plot model of regression 2, and then we're going to say type int. And again, the idea on this is that remember, we used another interaction plot, and that comes from a different package. Actually, this one comes from the interaction plot package. So you can use either this package or this package, the sjplot. Now, the sjplot package actually has a little bit more than the interactions package, because it's able to plot interactions between variables that are not necessarily numeric. So the interactions package only plots when the two variables are numeric for the interaction. So I'm just showing you another example. So I'm just going to go ahead and put this here in quotes, int. And let me show you what this interaction means. Okay, so we said as the weight of the car increases by 1,000 pounds, then on average, the miles per gallon decrease by about 0.593, which is that for Ford cars. You can see that the decrease is not as steep. But now, if the weight of the car increases by, if the car is a GM, then the decrease is a lot more. The heavier GM cars, then the decrease in the miles per gallon is actually more pronounced than those of Ford. Okay, so that's again another way to visualize these. The interaction is significant because these slopes are not parallel. They are actually different from each other. So that's what it means to have a different. That's what it means to have an interaction plot. An interaction effect present. Right, so again, I'm not gonna go ahead and you don't need to know about this interactions package and this actually SJ plot package. These are mostly for visualization purposes. If you have to just take a look at and you have to explain in a presentation to someone or about an interaction effect, then I suppose it probably would be nicer if you just show a graph as opposed to just the parameter estimates. So the graph actually might make more sense for people who are more visually oriented. But the one thing I will mention is that the plot model, the way that it works is that it looks for the object regression 2, and then it looks for the first interaction that it finds. So if you have more than one, it's just going to plot one at a time, and then it plots it. It plots the interaction between the variables. It puts the variable weight in the y-axis, the numeric one on the x-axis, and then it plots the categorical one on the y-axis, and it does that by default for every interaction that you have on the model. So you might, if you run this with more than one interaction, so you might have to look for the different plots that it creates. Again, no need to know about that package. There are more packages that do interactions. So if you find something else, if you Google around for interaction plots, you likely find a few of them out there. All right, so this is an example of an interaction between a quantitative variable and a qualitative variable. Remember that you are going to have an interaction for each one of the dummy variables. So if you have more than one dummy variable created, then you would have another interaction between weight and the level of the other dummy variable created, but you would interpret it the same way. You would actually be better off by just putting the example of both cases, because the dummy variables are only 0 and 1, so you would actually be better off just explaining the effect for those two levels. All right.